So here we are into chapter 14 now. So back to straightforward, pretty straightforward calculations. So let me fix this here. Pull that in. So determine the solubility of N2 in water exposed to air if the atmospheric pressure is 2 atmospheres. Assume that the mole fraction of nitrogen is 78% or 0.78 in air, and the Henry's law constant for nitrogen in water is 6.1 times 10 to the minus 4th molar. So pretty straightforward because Henry's law says that the solubility of whatever gas we're dealing with is equal to this Henry's law solubility constant times the pressure of that gas. And in this case, we have a mole fraction for nitrogen equal to 0.78, and the pressure is equal to 2 atmospheres. So the pressure of N2 is going to be given by that mole fraction times the 2 atmospheres, and that gives us 1 equals 1.56 atmospheres is due to the nitrogen. So we'll just plug this guy in here. It's going to be the solubility is equal to the Henry's law constant, which is given in the problem, 6.1 times 10 to the minus 4th, and that is molar per atmosphere multiplied by 1.56 atmospheres. And that gives one of the answers. The answer I got is 9.5 times 10 to the minus 4th molar. That's problem. So question number 13 is mostly just of a knowledge type question. Which of the following statements is generally true? So we'll look at all 5 of them and see which is the truest. So the solubility of a solid is not dependent on either temperature or pressure. Now that's just not true. We know solubility of solids increases with temperature. And the pressure can have some effect too, but it doesn't matter. Solubility of solid is not dependent on either, and it's not true. So the second one then is solubility of solid is highly dependent on temperature. Yes, that's very true. What temperature you have depends on the solubility. Solubility of solid is highly dependent. Now that's not true. So that's why that first one's a little bit of a tricky answer. And then 4, the solubility of a solid is highly dependent on both pressure and temperature. No, it is dependent on the temperature. That's the answer in this case. So here is problem 14 now, and we're into chapter 14, so this is a solution of 0.044 molal. Now that's molal lithium fluoride. What is the molarity? So, and then it gives us the density of the solution as well. So here's what we have. We know it's 0.0440 moles lithium fluoride, and that is per 1,000 grams of solvent. So it's H2O, so solvent. And what we need to get to is moles per liter of the solution. And we're going to use the density to do that. But now remember the way these are made, that we've got our container here, our volumetric flask, and we first fill it up to our 1,000 grams of our solvent, and then we add in our, in this case, 0.0440 moles. And what that's going to do now is give us a total mass that is going to be greater than 1,000 grams. We add those together. We know a density, so if we have grams of our solution, multiply by 1.10 grams per 1 milliliter, grams, that's going to tell us how many milliliters on the solution. That goes in there. We already know our moles, and that's how you do that problem. So molality is per grams of solvent. You add the moles, the grams that are equivalent to that number of moles, add them together, and that will give you that molarity, and that's that problem.